the inverse sine of x is restricted to this interval. And what this is the fourth quadrant in a negative direction and the first quadrant in a positive direction. So that's where the inverse sine will always go. And then the inverse cosine, or the arc cosine as we're calling it in this particular problem, is always between 0 and pi. So this is the first quadrant and this is the second quadrant. So the inverse cosine is an angle in the first or second quadrant from 0 to pi. All right. The inverse sine is always going to be an angle in the fourth or first quadrant. Okay, the fourth quadrant in a negative direction from 0 to negative pi over 2, and then from 0 to pi over 2 is the first quadrant. All right, so those two facts are absolutely huge. So it would make no sense for the inverse cosine to be anything other than an angle in the first quadrant or the second quadrant. It has to be there. Can't be anywhere else. All right, so what are we looking at here? We're looking for the angle or the arc whose cosine is negative 1/2. All right, arc cosine is in the first two quadrants. What's our reference angle if the cosine is 1/2? Pi over 3. All right, so pi over 3 is what we're looking for, or some variation of pi over 3. Which quadrant is it going to be in if it's negative? The second quadrant is where the cosine is negative, so I need to put pi over 3 in the second quadrant. Oops, I don't want to do that. Put pi over 3 in the second quadrant. What angle is pi over 3 in the second quadrant? You can use your unit circle or you can use your table of values. What angle is that? 2 pi over 3 is correct. All right, we're looking for second quadrant pi over 3, which is 2 pi over 3. Now, these are all pretty simple when they're straightforward, but there's a tricky way to ask these questions that you'll see from time to time. I'm not going to ask you a bunch like the tricky ones that we're going to look at, but it's going to kind of make you really know what these things mean. Arc cosine is always going to be between 0 and pi, and inverse sine or arc sine is always between negative pi over 2 and positive pi over 2. All right, now before we move into tangents, let's complete our table of values for tangent. Right, so tangent is sine divided by cosine. So if you go back to what you did yesterday, you can go to that table, and we're just going to do sine over cosine for these values on the bottom. Get tangent of theta. 0 divided by 1 is 0. That's going to be 1 over the square root of 3. This is 1. This is the square root of 3 over 1. And this is undefined. Right? And that's just by tangent. Sine over cosine is tangent. Sine divided by cosine. Because all the numerators are 2, they just cancel each other out when you divide them. All right, so when we're dealing with the inverse tangent, these are the only really 4 values you'll ever see for the inverse tangent. You won't see this one much. You just won't see it. Okay, in a practical sense. So what's the inverse tangent of 1? What do we have to answer first? What quadrants it's in. That's exactly right. Okay. Now, because of the way the tangent function looks, the tangent function behaves really. Because of what the tangent function looks like, the tangent function behaves really, really nicely between these asymptotes at negative pi over 2 and positive pi over 2. And so they're going to restrict the inverse tangent to that interval of output values. So the inverse tangent of x is always going to be, just like the sine of x, between negative pi over 2 and positive pi over 2. And if we're going to use this verbiage, let's use y there instead of x. But I really like to see it written like this. Negative pi over 2 is less than or equal to the inverse tangent of our x, our angle, our theta, whatever the angle is, or not the angle, the number, and that's pi over 2. All right. Now, one other thing, guys, that's different about the tangent function, I have to remind you about this. While the cosine and the sine just bounce around between positive 1 and negative 1, we could talk about the inverse tangent of 23. Right? Because the tangent of an angle can be larger than 1. It's the opposite over the adjacent. All right? So we could draw the inverse tangent of 23. Here's my angle x, this is 23, and this is 1. So we could draw that angle that has a tangent value of 23. It's going to be a pretty big angle, approaching 90 degrees, approaching pi over 2. So at any rate, it's not restricted, the input of the inverse tangent is not restricted like the input of the sine and cosine. The output is still restricted, though, because it's a function. So first quadrant and fourth quadrant is where we're talking about restricting the inverse tangent to. And which one of those quadrants is the tangent positive? Okay, which one of those is here? This is the fourth quadrant and this is the first quadrant. Which of these two quadrants is the tangent positive in? The first quadrant, right? So what's the reference angle if the tangent is 1? Pi over 4 in the first quadrant is what we're looking for. So that's just going to be pi over 4. It's really straightforward when it's a positive angle and positive quadrant. First quadrant angles always get mapped right back to first quadrant angles. It's not as simple with the other ones. Okay, now, you ready? Inverse tangent of negative 1 over the square root of 3. This angle that we're looking for, this angle right here that we're looking for, has a negative tangent value. And because the inverse tangent is restricted to the first quadrant or the fourth quadrant, we have to use the fourth quadrant, right? Because the tangent is positive here, the tangent is positive in the first quadrant, the tangent is negative in the second quadrant. And so the angle we're going to use is pi over 6 in the fourth quadrant. What is that? Which pi over 6 value in the fourth quadrant do we use? Can we use 11 pi over 6? Now, 11 pi over 6 starts right here and goes all the way around to there. Can we use that one? We can't use that one. The angle that we use has to be, we've got to remind ourselves of this, between pi over 2 and negative pi over 2. 11 pi over 6 is not in between those two values. So we've got to get to this fourth quadrant angle by going in a negative direction, and that's going to give us negative pi over 6. It's the same, it's coterminal with 11 pi over 6. All right, so that's the sticky part of this inverse tangent functions. We can't use any angle that has this particular tangent value. We have to use this specific angle because the tangent is restricted to these boundaries. Inverse tangent is restricted to those boundaries. Okay? Yes? Y'all are looking at me blank and I don't know what that means. What does that mean, Lindsay? You missed yesterday, so you'll catch it. Or not. Choice is yours. All right, you can go back and check out the video from yesterday. All right, so this is negative pi over 6. Now, a few tricky problems. And when I say these are tricky, they are tricky. So you got to really, really stick with it. The reason we use inverse cosine functions is to solve trig functions, because the inverse cosine is the inverse of the cosine, just like the square root is the inverse of the square. The cube root is the inverse of the cube. So one undoes the other, but not directly. Okay? Because we have to remember the restrictions of this. Now, here's the problem. This first one is pretty easy. Where's the inverse cosine restricted to? Let's remind ourselves of that. It's between 0 and pi. Is this angle between 0 and pi? Yes. And because it's between 0 and pi, then it just directly comes out as that. The inverse of the cosine is that angle, but only when the angle is between 0 and pi. If the angle is not between 0 and pi, the inverse cosine is going to spit out a different angle. For example, okay, the inverse cosine of the cosine of negative pi over 4. Let's remind ourselves that the inverse cosine, output of the inverse cosine, is between I don't like the way this is written. The inverse cosine of an angle is between 0 and pi. I wrote it wrong again. Is this angle between 0 and pi? It's not, is it? Right? It's the opposite direction. This angle is actually in the fourth quadrant, which is not between 0 and pi. So this answer is not negative pi over 4. Can't be. We want it to be because the inverse cosine undoes the cosine, right? But, you know, in this sense, it gives us a different value. What's the value going to be? The cosine is what? Positive or negative in the fourth quadrant? All students take positive, right? So this is positive. This angle has a positive cosine value. And this is the first quadrant, and then the second quadrant over here. Where's the cosine positive between the first and second quadrant? First quadrant, right? And so this is also pi over 4. Yeah, I know. What do you want it to be, Dalen? See, you want it to just be negative pi over 4, right? Because the inverse cosine undoes the cosine. But the inverse cosine is restricted to first quadrant, second quadrant. Why first quadrant and second quadrant? Because the first quadrant for cosine would get all of our positive cosine values, and the second quadrant gets all of our negative cosine values. That's where the inverse cosine lives. It does not spit out numbers outside of first quadrant and second quadrant. The inverse cosine lives between 0 and pi. It must. It's restricted to that. So we can talk about it as a function. Okay? The cosine of pi over 4, negative pi over 4, the cosine of negative pi over 4 is positive. So it has to go to the positive quadrant for the inverse cosine, which is the first quadrant. And the reference angle is pi over 4 in the first quadrant. Okay? Let's look at another one, because I can tell y'all are just not seeing that. And look, I wasn't kidding. It's tricky. Your calculator will do this. Everybody get out your calculator. And let me show you what the calculator will do with this. There's some right there on that shelf if you'd like to grab them. I don't know what the button keystrokes are. This is a trig class. It's pretty important to have a calculator with you. All right. Put your calculator in degree mode, which means we're going to switch these things around. And in your calculator, do the inverse cosine of the cosine of negative 45 degrees. You don't have to do degrees. You just put 45, and if it's in degree mode, it understands that's an angle, and it converts it to degrees. It tells you it's 45, right? Now, do you believe me? Okay. And that's the way it's always going. It's going to work that way. Your calculator's going to send this to either a first quadrant value or a second quadrant value. That's where the inverse cosine will always come out. That's why when we were solving triangles, we were perfectly okay to go first or second quadrant. Law of cosines works great with obtuse angles. The law of sines works terrible with obtuse angles because it sends obtuse angles to the fourth quadrant. Negative angles. It gives you a negative value. Okay? And that doesn't work. All right, let's look at one more of these. Let's do the inverse cosine of the cosine of 4 pi over 3. Now we really want the answer to be 4 pi over 3 because the cosine and the inverse cosine undo each other. But that's not the way it works. Where does the inverse cosine live? It lives between 0 and pi. Is 4 pi over 3 between 0 and pi? It is not. Okay? Now, where is 4 pi over 3? That's in the third quadrant, and the cosine is negative there. So this is going to go either to the first or second quadrant. Where is the cosine negative between those two quadrants? The second quadrant. Pi over 3 in the second quadrant is 2 pi over 3. Yes?
Why wouldn't that be negative 2 pi over 3?
Because negative 2 pi over 3 is not between 0 and pi. 4 pi over 3 is negative 2 pi over 3 for all practical intents and purposes, but we're restricting the inverse cosine to the first or second quadrant. And again, if you wanted to look at this in your calculator, it will tell you that the inverse cosine of 4 pi over 3 is 240.
But this time, if you have students who are in the brass section of the band, they need to go on down to the band room, and at 12:45, any students in the woodwinds section of the band need to go to the band room. So brass now, woodwinds at 12:45. Thank you.
All right, so y'all watching this? If you punch this in your calculator, it's going to tell you that it's equal to 120 degrees. Confirm that. You're in radian mode. Yeah. So you have to be in radian mode. Oh, excuse me, degree mode. Degree mode. Bring your calculator here and let me look at it. I'm not sure what the syntax is on that calculator. The question is, how do we get 2 pi over 3 here? And it's because, again, and I know I'm being repetitive, but I don't know how else to answer the question other than to repeat it until it sticks. The inverse cosine is restricted to 0 to pi. That's the first quadrant and the second quadrant. It can only output values that are there. We know our reference angle is pi over 3 because we have pi over 3 as our reference angle right there, right? This is negative because the cosine of 4 pi over 3 is negative, and that means it has to go here where the cosine is negative. If the cosine was positive in the quadrant where the angle is, then we would send it back to the first quadrant. If it's negative, we send it to the second quadrant. The inverse cosine sends it to either first quadrant or second quadrant. First quadrant if it's positive, second quadrant if it's negative. So pi over 3 in the second quadrant is 2 pi over 3. Let's do this. Let's do a few more of these related to sine. Okay? The inverse sine of the sine of pi over 3. The inverse sine of the sine of pi over 3. Now, where does the inverse sine hang out? It's negative pi over 2 is less than or equal to the inverse sine of x is less than or equal to pi over 2. So, guys, as long as this angle that we're dealing with is in that interval, then that's the angle that's going to come out. So this is pi over 3. It works exactly the way we want it to work. But if we go outside of, what are these quadrants here? Quadrant 4, quadrant 1. If we go outside of quadrant 4 and quadrant 1, the inverse sine is going to send it back to quadrant 4 or quadrant 1. Quadrant 4 if it's negative, quadrant 1 if it's positive. All right, so let's look at another example. Sine, inverse sine of the sine of 4 pi over 3. Sine of 4 pi over 3. That's 3 pi over 3 plus another pi over 3. This is firmly into which quadrant? Quadrant 3. And the inverse sine is not going to send it to quadrant 3. It's going to send it to quadrant 1 or quadrant 4 in a negative direction. All right? So, inverse sine of a number is between pi over 2 and negative pi over 2. That's quadrant 1 in a positive direction. Quadrant 4 in a negative direction. Reference angle is pi over 3. So if it's in the first quadrant, it would be pi over 3. If it's in the second quadrant, it's going to be negative pi over 3. Which one is it? Alex, which one is it? Negative pi over 3? Is that right? Is the sine of 4 pi over 3 positive or negative? Sine is negative in that quadrant. And so we're going to be right here where the sine is negative. Negative pi over 3. Yes?
Okay, so depending on what the sign, like if it's positive or negative, whenever you look at the angle on if it's in like a different quadrant, that determines if it's going to be positive or negative for your answer.
That's correct. Yes. The inverse sine can only send it to the first quadrant or the fourth quadrant. First quadrant if it's positive, fourth quadrant if it's negative. So when we're dealing with, like this case, we're dealing here with this third quadrant angle, sine of 4 pi over 3. That's third quadrant, where the sine is negative.
So the answer's going to be negative.
The answer has to go to the fourth quadrant because that's where the sine is negative. Yeah, and with the inverse sine, it's going to be negative values go to negative angles directly. It doesn't work that way for cosine. For cosine, negative values go to the second quadrant. For tangent, if it's negative, it'll be negative. For cosine, it goes to the second quadrant. Inverse cosine is only spitting out positive values. I think you guys are getting this a little better than third period, but I've done a little better job of teaching it because I had the benefit of their confusion. Okay? You want to do one more of those? let's do one more. Let's talk about degrees. Let's do the inverse sine of 150 degrees. Is this positive or negative? Is the sine of 150 positive or negative? It's positive. What's the reference angle? 30 degrees. So this is 30 degrees. All right, so the moral of the story here is that the inverse sine function does undo the sine function, but not directly unless it's in the range of the inverse sine function, the inverse cosine function. Now the good news is you won't see very many of these at all, these tricky ones. I just wanted you to think about it, and it helps you to understand the restrictions that are on the output of the inverse sine and the inverse cosine and the inverse tangent. Okay? There you go. Band people, or if y'all have to go soon, you don't have to go at all. Oh yeah, yeah.